Now, when testing these motor blocks that are taken out of the GP40, and these were the problem motor blocks out of the Rock Island road number 378 that I have, in order to test them by themselves, I put these little jumpers that you can see here that I'm pointing to, and the little jumpers serve to jumper the pickup electrical connections from the wheels to the motor itself. And so there's one jumper required for one side and the other jumper required for the other side. I just took a very small diameter wire because you don't want to, put something too big in and relax the spring tension contact on this connector. So I put some very small wire size in there to jumper the two inboard connections and the two on either side of the connector here. You see the two little loops here. So that allows the motor to be run by itself, independent of the loco. This video will demonstrate excessive current draw from Aristocraft GP40 motor blocks once they've been removed from a unit. In this case, it's a Rock Island road number 378. It's upside down here where I've taken it apart to remove the motor blocks. I've done another video with the motor blocks installed in this loco, and this video will demonstrate the motor blocks as a pair and by themselves having been removed from the loco. I'm using an oscilloscope here to measure, as I did with the first video, what's going on. The upper trace, there are two traces sweeping the scope here on the screen. The upper trace represents current in terms of voltage, and it's basically 1 volt per centimeter with the gradations on here. The lower trace represents the voltage applied to the motor blocks, and the reference is on the bottom trace here. So this happens to be calibrated for 1 volt per centimeter, and the lower trace is calibrated for 5 volts per centimeter. And this is the Train Engineer, the latest one made. I don't believe they make them anymore, but I was able to purchase one recently. And this is the Train Engineer here, and this is the newer transmitter, the latest transmitter that goes with it. And this happens to be an Everest power supply. On the top it's labeled CRE 55465, but on the front it's labeled CRE 55468, which I believe is the more correct number. So this is apparently an early prototype one. And here are the two motor blocks. They are mounted on Bachmann rollers for test purposes, and the power is being supplied through a Dale resistor that happens to be in series with the power leads to the track, and it's a 1 ohm resistor, and again 1 volt divided by 1 ohm is 1 amp, so I'm using a means to convert voltage to current so that it can be displayed on the oscilloscope here. So in this case I'm putting both motor blocks on the rollers, and they are running at 5 volts, which you can see here in the lower trace. It's 5 volt per centimeter, and the upper trace represents the current draw. Now the current draws can be seen here is about an amp, because there's a reference 0 in the center, and it's about roughly an amp here, or 1 centimeter. So that's about 2/10 of an amp with the same motors, or 2/10 of an amp less with the same motors when they were mounted in the, or motor blocks when they were mounted in the locomotive itself. So there may be some electronics that is contributing to that additional 200 milliamp draw. So in this case, I wanted to demonstrate that there's still excessive current compared to motor blocks that don't seem to draw that much, like in this Union Pacific example, which I had demonstrated in the previous video. So in that locomotive drew about 6/10 of an amp approximately under the same conditions, and here it is with the motor blocks out of this Rock Island road number 378 unit I have that's problematic, and it draws a really more an excessive amount of current. Now while I have both of these motor blocks running that have been taken out of the Rock Island Road number 378 unit that are problematic in that they draw excessive current, or at least one of them does, and I thought I'd demonstrate while I'm at it how the excessive amount of distance that is allowed for the axles to go back and forth. And if I run these up at a higher speed, you can see the attitude that the axle is with respect to the motor block. There's more of a gap on this side than on this side. And this is the front truck. There's the rear axle of it. And this is the rear truck. And notice that the gap in this direction, there's quite a bit of gap with the motors rotating or the wheels rotating in this direction, and then compared to this side here. The gap between the motor block and the wheel is almost non-existent here, or minimal, and the gap on this side is quite a bit. So if I reverse the direction, now notice how the axles move to the opposite ends. And that cannot be too bad. This is the front truck here. This is the rear truck here. Now that cannot be too beneficial for the way the gears mesh. You'd rather have something optimal with the axles displaced about an equal amount. Now on a 3-axle truck, you want to have some lateral play. The trucks such as in the SD45 or the E8s or the Dash 9s. But in this case, there's no reason to have these things displace this much lateral movement. And not only the gear mesh issues may be an issue, which may compromise if they would fail or not under a heavy load, but also I've discovered when you're using body mount KD couplers and even Aristo couplers that the loco can move itself from side to side on the rail, enough so where the couplers won't engage or they will engage depending on which way it favors. Now I have removed the rear truck from the problematic Rock Island GP40 road number 378. It's now taken off the rollers and put aside, so the only one that's being powered now is the front truck from that unit. And as you can see, it's rotating here. I had marked the rollers with a marker pen so they can be seen going around front and rear. And on the oscilloscope we can see that the lower trace is still at 5 volts here, and the upper trace is representing current at 1 amp per centimeter with the center as reference 0. And it's this motor block by itself is running about 6/10 of an amp, and that's roughly what this Union Pacific locomotive draws in its entirety when placed on the rollers, as was demonstrated on a previous video. So this Union Pacific example has yet to develop a motor failure. So that's rather significant, I think. And if I run up the speed hun here, we can see some interesting phenomena. And you can see these little peaks here. They apparently represent the commutator as it's going around. And the scope may or may not synchronize here properly. I've tried different methods of trigger that it has available, but this seems to be the best. So if I run it up here, see the voltage is increasing to 10 volts, because in this case the channel 3, that channel is 5 volts per centimeter, so there's 10 volts applied to the track over here. And these little peaks become closer together, higher speed, which makes sense. If I run it up even higher, you can see that now it's running at 15 volts here, and this represents a fairly high current where you see these little spikes coming up, and when it's dropping down it's a lower current value. And here the motor is and the truck is going at a pretty good clip speed-wise. So we'll compare that to the rear truck. So I'll run the voltage back down. To 5 volts. Now I have switched motor blocks. I've taken the front truck that came out of the Rock Island road number 378 unit that draws a lot of current, and took it off the rollers here and placed the rear motor block onto the test track here on the rollers. And we can see the rollers are turning there. And again, I have applied 5 volts to it. The bottom trace is 5 volts per centimeter, channel 3 connected to the track here. So now this motor block draws a notably less current and less peak-to-peak ripple that you see on here, which represents the, I believe, the commutator as it's switching. So at any rate, we can see that it's about 0.4 of a volt as an average, and that's 0.2 of a volt less than the front motor block. So I'll run this one up to apply 15 volts to it, like I did the first one. And there's about 5, 10, 15 volts. And notice the current, there's somewhat of an excursion due to the commutators here, apparently. But still it's maybe averaging a ½ amp, and that's less than the less severe than the front motor block was. Here we can see it running at a fairly high speed. So it appears as though the front motor block is more of a problematic element in this Rock Island locomotive. And so the next step is to replace the motors. Since I've got a new pair of motors from Aristocraft, they were gracious enough to send me them. I think I'd prefer to replace the motors in each of these blocks as a pair. Here I have replaced the bad motor in the Rock Island road number 378 logo, the front truck. And here's a picture of the bad motor that I took out. I labeled it with some tape here. And this is a replacement motor below it, the replacement motor that I'll eventually put into the rear truck. And the replacement motor now is operating in the front truck here. It turns out the new motor is about 15 thousandths longer in its housing length. It's about the same diameter, and there's a slight more protrusion in the front where the shaft comes out. You can see the differences here. The one with the blue tape is the bad one I took out of the front truck, and this is the second replacement motor is I'll put in the rear truck is in the foreground here. So there are some differences in the new motor. Doesn't have any identification markings on it at all, or any kind of stamping indicating what manufacturer it's come from. The old motor here with the bigger slots and the blue tape has bigger vent slots, a slight difference in the plastic where the brush is apparently attached on the interior, which is hard to see here. And the rears look very similar, and the little hex shaft that's pressed on seems to be sticking out a little bit farther on the replacement motor. Excuse me. And the brass bushing is exposed such that it looks like you could take the new motor apart much more readily than the other one. So at any rate, I have this new motor in the truck mounted. Because it's slightly longer, I had to file off some of the internal ribbing, which wasn't too difficult to do. It took some time. And here is the scope waveform. It's running at 5 volts, and it's drawing maybe slightly less than a half an amp, so that looks quite good. And if I run it up in power, you can see the commutator waveform increasing, but the current's increasing maybe slightly, still averaging around a half amp, maybe slightly higher. So if I run it up to 15 volts, that's the waveform, and here it's running quite briskly. So the current is quite reasonable in this one. And there it is with 5 volts applied on the indicated on the lower trace here, and it's averaging maybe slightly less than a half an amp here. So there you have the demonstration. Correction on the motor length. The motor length is about 35 thousandths longer. It does vary somewhat depending on where on the housing you measure across from. But from the flat parts here across the new motor, it's about 35 thousandths longer than the older motor that was taken out. And again, it does require some rib trimming on the interior cradle, the upper cradle here, in order to fit the new motor in, since it will have more or less an interference fit and you won't be able to get it in. But it isn't too bad to do. This is the rear truck, the rear motor assembly that's been taken apart on the Rock Island number 378 unit. And this motor is the new motor, and this motor is the one that was in there, and the new motor is about 35 thousandths inches longer than the existing motor, and there are little ribs in here. These two ribs might be difficult to see, but they have to be trimmed almost flush, not quite flush with the bulkhead here, and all the way down into the cavity of the farthest depths of the motor cradle here. And so you have to have some finesse, and you can use a file and also an X-Acto to get it squared up. It's important to get it squared up all the way down to the cradle here at the end on both sides here. And that way the new motor will fit in nicely. You shouldn't force the new motor in, because if you do, you'll end up, and it looks like it's rather fragile, you could end up bowing the cradle assembly if you try to force the new motor in. So it should drop in reasonably well. As you take the motor assembly apart, these little gearboxes pull off of the hex shafts fairly easily, and you can see how the wiring is here. And there's a red dot on the motor down here, maybe hard to see, and there's a red wire that goes to that, and the brown wire goes to the other lug. If you mix them up, the motor will turn backwards from what it's intended to, so you will have one truck fighting the other conceivably, or one loco fighting another, if you don't do it right. And this circuit board here that has the overload voltage protector on it has to be unscrewed, 2 little screws here, and that provides enough service loop so that you can pull the motor out a little bit and work on it with the soldering iron. Now here I've replaced the motor in the rear truck of the Rock Island 378 road number unit, GP40, and here's the front truck that I had replaced. The bad motor already, and the pair of them now are running on the track on rollers. And you can see that was the original motor that was in there, and the new motor is in there now. Same for the rear truck. And here's the oscilloscope display, and it has 5 volts applied to track voltage, and the current is under an amp. It's about 0.8 of an amp, averaging with both trucks operating. So that's quite an improvement over what it was, which was as much as 2 amps before. And there's the end of the demonstration.